Hello. Now that you have learned the fundamental concept of shadow prices in duality theory, let us now discuss a theory in duality theory that talks about the primal and dual problem. Under duality theory, it is said that there are what we call primal and dual problems. And in this case, the primal problem is the given optimization model, the one formulating the application of primary interest. In simple terms, the primal problem is our main linear programming problem. Okay? And because there is a primal problem, according to duality theory, there exists a dual problem. And this dual problem is a subsidiary optimization model. So yes, it is still a linear programming model. No? It's a linear programming optimization model. This dual problem is defined over the same input parameters as the primal, but this dual problem characterizes the sensitivity of primal results, or in this case, the optimal z-value, to changes in the inputs. Now, let me go to the red blue gadget problem as always and explain what the primal and dual problem is. As you may have remembered, this is our red blue gadget problem. Maximize z equals 500x1 plus 300x2, subject to 2x1 less than or equal to 1000, 2x2 less than or equal to 1, 2, and 3x1 plus 2x2 less than or equal to 1, 8. And according to duality theory, and if this is the main linear programming model, then we can say that this linear programming model is our primal problem. It is the given optimization model, the one of our main primary interest. Okay? And according to duality theory, if this primal problem exists, then there exists a dual problem. Now, without explaining how we are able to get the dual problem, let me first show you what the dual problem looks like, or what the dual problem of the red blue gadget problem looks like. Okay, as you can see, this is the dual problem of the red blue gadget problem. And what I'd like you to do is to take note of the variables. There are three variables, y1, y2, y3, and look at the coefficients that are being used. Okay, so as you can see, you have 1000, 1218, you have 203 for the coefficients of the first constraint, and then you have a right hand side of 500, and then you have the coefficients 0 to 2, and the right hand side of 300 for the second constraint. Now, according to the definition of the dual problem, the dual is a subsidiary optimization model. So in this case, the dual problem exists because the primal problem exists. And in this case, the dual problem is defined over the same input parameters. What do we mean by that? In the red blue gadget problem, if you look at the red blue gadget problem, the input parameters, the parameters are the coefficients. So 500, 300, 2, and then the 0 here, 0, and the 2, and 3, and 2. Okay? And of course, your right hand side is 1000, 1, 2, and 1, 8. And as you may have noticed, these input parameters are the same input parameters used in the dual. Everything was used in the dual. Okay? However, however, the dual problem in this case characterizes the sensitivity of primal results, or in this case, characterizes the sensitivity of the optimal z-value to changes in the inputs, especially the right-hand side. So let's try to understand that. If the dual problem characterizes the sensitivity of the z-value to changes in the inputs, then we are exactly talking about shadow prices. Why? Because the shadow price, by definition, is the change. So it's how sensitive, no, your primal results are, or your optimal z value are, no, to changes in the inputs, especially the right hand side. So if I were to use this example, the dual problem of the red blue gadget problem, I will define y1 to be the shadow price of the steel constraint, y2 to be the shadow price of the wood constraint, and y3 to be the shadow price of the labor constraint. Okay, so the question now is, how do we get the dual problem of a primal problem? Okay, in order to get the dual problem of a primal problem, we need to determine first how many variables and how many constraints there will be. And in this case, uh, there is one dual variable for every main primal constraint. Remember, the dual variable is defined to be the shadow price of your constraints in the primal problem. And therefore, each primal constraint will correspond to a dual variable. And this dual variable reflects the rate of which um, uh, the rate of change in primal optimal values per unit relaxed from the given right hand side of the corresponding constraints, or as we know it, the shadow price. Now, because we have a dual variable for every primal constraint, we can also uh, observe that in this case, for every main variable in the primal problem, there will be a corresponding dual constraint. Okay? And I will explain later why there will be a dual constraint for every main variable. No? Our focus right now is how to convert how to get the dual problem from the primal. Okay? So So now we know there is a dual variable for every primal constraint, and there is a dual constraint for every primal variable. Now, in order to convert or get the dual model, the first thing you have to do is to standardize your primal problem. And what do we mean by standardize? Um, as we know, there are two kinds of objective in every linear programming model. It's either you maximize some benefit function or you minimize some cost function. Now, if your objective is to maximize, the first thing that you have to do is to convert all your constraints into less than or equal to constraints. What do we mean by that? If your objective is to maximize and you have a greater than or equal to constraint, then all you have to do is negate both sides. By negating both sides, you now convert your greater than or equal to constraint into a less than or equal to constraint. In the same manner, if you have a minimization problem, no, and you have, let's say, less than or equal to constraints, then you have to negate both sides in order to convert your inequality to greater than or equal to. Okay? To summarize, the first step is to standardize the primal problem. Again, standardization means if you have an objective function that is a maximization, convert all constraints into less than or equal to. If you have a minimization problem, convert all constraints into a greater than or equal to constraint. Now, if ever you have an equality constraint in your model, the first thing that you have to do is to convert this equality constraint into the intersection of two inequalities, no? Greater than or equal to and less than or equal to. Now, just to explain, if you have an x equals 4, this is actually equal to an x less than or equal to 4 and x greater than or equal to 4. Okay? And then all you have to do is convert one or the other according to the standard form. Okay? Now, after converting the primal problem into the its standard form, The dual problem should also be in standard form. However, it will have opposite objective. It will have an opposite objective. What does that mean? If the primal problem is to maximize, then the dual problem is to minimize, and vice versa. No? And in order to get the finally to get the dual problem, all you have to do is get the parameters or the coefficients in the primal problem and transpose. What do we mean by transpose? For every row in the primal problem, it becomes a column in the dual problem. For every column in the primal problem, you will convert it into a row in the dual problem. And that supports our discussion a while ago that for every primal constraint, so the primal constraint refers to a row in the primal problem, we have a dual variable which pertains to a column in the dual problem. And for every main variable in the primal problem that pertains to a column in the primal problem, we have a dual constraint. No? So you have a row in your dual problem. Now, in order to understand how to convert your primal problem into the dual problem, let me give a very specific example. We have this family diet problem. A family needs a weekly requirement of 20 units of vitamin A and 30 units of vitamin C. They are able to get these vitamins by consuming 5 different food items. Information about the 5 food items are given in the table below. And what we'd like to do is we'd like to develop a linear programming model that will minimize the total cost of meeting the weekly minimum vitamin A and vitamin C requirements of the family. So we have this table. no? Uh, just to explain quickly the table, we have the 5 different food items, food 1 until food 5. And in this case, when the family consumes a pound of, let's say, food 1, the family will be able to get 2 units of vitamin A from it and 0 units of vitamin C. And in this case, every pound of food item 1 is 10 pesos, let's say. No? And you have the information for all 5 food items, no? And the associated costs. And of course, the minimum requirement, weekly requirement of 20 for vitamin A and 30 for vitamin C. So what we need to do right now is to first develop the primal problem. Okay, so let me go to our whiteboard, and I've placed here the table that we need in order to write or develop the linear programming model. So what we have here are 5 variables. So let x sub I be the number of pounds of food I purchased or consumed, no? Okay, by the family. Now, because your variables are x sub I, then our objective is to minimize our total cost function. And our total cost function is 10x1 plus 14x2 plus 18.5x3 plus 13.75x4 plus 32x5. And we want to subject this objective to the following constraints. What are the constraints? First, you have to have at least 20 units of vitamin A. And in this case, how much vitamin A will you be able to get? It's 2 units for every pound of X1 plus, well, of course, 0x2 in this case, plus 3x3 plus 1x4, and finally plus 4x5. x5. Okay? And then we have another constraint for vitamin C. 0x1 plus 3x2 plus 1x3 plus 2x4 and finally plus 3x5. And this has to be greater than or equal to 30. Of course, you want your variables x1, x2, x3, x4, and x5 to be greater than or equal to 0. Okay? So now, uh, let us review how to get the dual problem. Okay? Coming from this primal problem. In order to get the dual problem, the first thing that you have to do is identify how many dual variables will the dual problem have. And in this case, remember that for every primal constraint, and we have two primal constraints, there will be a corresponding dual variable. So let me define the dual variable here to be y1, okay? Or if you want for it to be clearer, no? Let's call it y sub a, the dual variable y sub a, which corresponds to vitamin A, and the dual variable for the second constraint, let's call it y sub c. Okay? And secondly, remember that for every primal variable, and in this case we have 5 primal variables x1 to x5, we will have the corresponding dual constraints, and therefore we will have 5 dual constraints. Okay? So let us now formulate our dual problem. So remember, our dual problem's objective is the opposite of the primal problem. Because the objective of the primal problem is to minimize, then the objective of the dual problem is to maximize. Okay? And we'll just use the generic z variable for the objective. Now, remember that the dual problem's parameters will be transposed. So all the coefficients here will be used, but in transposed. Okay, which means if the coefficients in your dual problem will correspond to your right hand side in the primal problem. Okay. So what are the right-hand side coefficients? We have 20 and 30. And we just have to get the sum product with the corresponding dual variables. So the dual objective is a 20 YA plus 30 YC. Okay? Subject to, and we have 5 primal variables here. Okay, and each column here will correspond to a dual constraint. So the first column has the coefficients 2, 0, and 10. Okay, which means this column will become a row in the dual problem. So we will have 2YA plus 0YC. And in this case, because this model is standard, what do we mean by standard? You have a minimization problem and all your constraints are greater than or equal to. Okay? That means your dual problem will also be standard. And because your dual problem is a maximization, then the inequality here will be less than or equal to. And the right hand side here, we will get the coefficient of your objective function, which is 10. Okay? Now, just to continue, for column x2, we have the coefficients 0 and 3. So that is a constraint 0YA plus 3YC less than or equal to 14. Next, you have 3YA plus 1YC less than or equal to 18.5. Next, 1YA plus 2YC less than or equal to 13.75. And finally, you have 4YA plus 3YC less than or equal to 32. And of course, you have your non-negativity constraints. So what we have here is our primal problem on top, okay? And our dual problem below. And how do we define our variables YA and YC? So let me define YA. So let YA be the, well, let me put it in quotation mark, the shadow price of vitamin A. And in this case, YC, again in quotation mark, shadow price of vitamin C. Okay? And in this case, just for the purpose of understanding the dual problem eventually, what I'd like to do is I'd like to put a description or definition on each of the constraints in the dual problem. Remember, the dual problems constraints came from the uh, primal variables. So in this case, the first dual constraint actually pertains to x1, which is food item 1. Dual constraint number 2 pertains to x2, this one x3, this one x4, and this one x5. So what I want to for us to do right now is to understand the dual problem. I think everyone knows or understands the primal problem because the primal problem is described by this family diet problem. No? So everyone understands why the objective function is 10x1 plus 14x2, etc., etc. And everyone understands why there are two variables here. Okay? But I don't think everyone understands in the first place why the objective of the dual problem is to maximize, and the objective function of the dual problem is 20YA plus 30YC, and why there are five constraints for the dual problem. Okay? Now, in order for us to understand the dual problem, it is important for us to understand first who owns the problem. If the primal problem is owned by the family, meaning the family is the entity that has this diet problem, then the question now is who has this particular linear programming maximization problem? So who owns this dual problem? Now, let me let me share with you an insight who possibly owns this dual problem. And remember, this dual problem only exists because the family has this particular diet problem. Okay, and the diet problem refers to them requiring vitamin A and vitamin C units. No? Now, let's say a pharmaceutical company knows that this particular family needs 30 units of vitamin A, 20 units of vitamin A and 30 units of vitamin C weekly. And let us say that this particular pharmaceutical company is able to produce vitamin A and vitamin C capsules. No? So, um, this particular pharmaceutical company is thinking, instead of letting the family purchase the different food items, no, food item 1, 2, 3, 4, 5, in order to get their vitamin A and vitamin C requirement weekly, why don't they market to this particular family vitamin A and vitamin C capsules? So instead of buying the food item, just buy the vitamin capsules from the pharmaceutical company. Okay? So, given that context, if I were the pharmaceutical company and I know that the family requires 20 units of vitamin A and 30 units of vitamin C, then the question now is how much should I be pricing my vitamin A and vitamin C capsules? And in that case, that will be the definition of my variable. No? Instead of the generic definition of YA to be the shadow price of vitamin A, I will now define YA to be the selling price of vitamin A. YC is the selling price of vitamin C. And because I am the pharmaceutical company and I plan to sell vitamin A and vitamin C capsules to the family, then I would like to maximize my profit. And that is why the objective function of the dual problem is to maximize this particular function, 20YA plus 30YC. Because in the end, if you look at this function, that's your total profit or revenue, whatever. Okay? Now, because I want to maximize my total profit and the number of units of vitamin A and vitamin C are already set, then in order to maximize my total profit, I need my YA, my variables YA and YC to be very, very big. Of course, I'm a greedy pharmaceutical company. I'd like to maximize my profit, so I'd like to set my prices to be very, very high. However, however, I cannot set my prices YA and YC to be very, very high because I need to take into consideration five different things. And what are these five different things? Let me first explain the first constraint, and hopefully if I am able to explain the first constraint, it will now be easy for us to understand the rest of the constraints. Okay? So let us look at the first constraint. 2YA plus 0YC should be less than or equal to 10. Let's try to understand this. Now, what are 2 and 0 relative to food item 1? What is 2 and 0 relative to food item 1? And let's go back to the PowerPoint. 2 and 0 are the contents of vitamin A and vitamin C in food item 1. Okay? So 2 is the vitamin A content of food item 1. 0 is the vitamin C content of food item 1. And remember our definition of YA and YC. YA is the price that we will be setting each unit of or each capsule of vitamin A. YC is the price of each capsule of vitamin C. And therefore, if you multiply 2 times YA, add it to 0 times YC, then this is the price that the family will have to pay if they will not purchase food item 1 and instead will just purchase vitamin A and vitamin C directly from the pharmaceutical company. Okay? So ito yung gagastusin nila if they opt not to purchase food item 1 and instead purchase directly the vitamins in capsule form. Okay? Now, if I am the pharmaceutical company and I know that the family will be incurring this cost, then the price that I'm willing to set for my vitamin A and vitamin C should not be very, very high such that this whole thing, okay, still has to be less than or equal to 10. Why? What is 10 relative to food item 1? 10 is the cost of food item 1. which means when the pharmaceutical company sets the price for vitamin A and sets the price for vitamin C, and if the pharmaceutical company computes how much is every pound of food item one in terms of the vitamins, then the effective price here still has to be less than or equal to 10. Why? Because if this whole thing is greater than 10, then the family will not purchase the vitamin A and C capsules. Instead, they will just purchase the food item 1. Okay? So to summarize, the pharmaceutical company has this particular constraint because because the pharmaceutical company wants to make sure that when they price vitamin A and vitamin C, it is still sulit, no? Sulit for the family. Sulit in what sense? That the family will rather purchase directly the vitamins from the pharmaceutical company instead of purchasing the food item. And that same analysis works for every food item. And as you can see, for example, this second constraint, 0 and 3 are the vitamin content of food item 2. And if you get the sum product of 0 and 3 and YA and YC, you get the value that the family will have to pay if they opt to get the vitamins in capsule form. And this amount that the family will have to pay will still have to be less than or equal to 14 para mas sulit, no? And you do that analysis for each and every food item. Okay? So yes, the pharmaceutical company would like to make sure that YA and YC is very, very high. In fact, the pharmaceutical company would like to maximize its total profit. However, they cannot just increase YA and YC to a very big amount because of these 5 constraints. So now, let us go back to the red blue gadget problem and its dual problem. And let's try to understand what the dual problem talks about. Okay? So again, looking at the primal problem, we understand fully what this problem is. Our objective is to maximize the total profit of the ABC company while taking into consideration the 3 constraints, the 3 supply constraints, which are your steel, wood, and labor. Okay? So in this case, let's try to understand using the same way and analysis that we did in the family diet problem. Let's try to understand the dual problem. Okay, so what is Y1? What is Y2? And what is Y3? Generically, we mentioned that Y1, Y2, and Y3 are the shadow prices of your steel, wood, and labor. Okay? Let's leave it at that first. Now, let's try to understand first who owns this dual problem. Remember that the dual problem exists because the primal problem exists. However, the dual problem is owned by someone else. Okay? In the example of the family problem, a family diet problem, the dual problem is owned by a pharmaceutical company that is deciding to produce vitamin A and vitamin C capsules. And in that problem, they are deciding how much to price each capsule of vitamin A and vitamin C. So for this red blue gadget dual problem, who owns the problem? Let's say there is a company that is in a different business, no, compared to the ABC company. So this other company is not producing red and blue gadgets, let's say. However, this particular company is also using steel, wood, and labor units. So in their production process, they are producing some other product, but they are using the same input materials. They are using steel units, wood units, and of course labor units. And let us say that this company would like to purchase ABC companies 1,000 units of steel, 1,200 units of wood, and 1,800 units of labor. Okay? So the context here is I'm the other company. I went to ABC company. Uy, can I buy your steel, wood, and labor? Okay? And because I am buying ABC company's steel, wood, and labor, I need to know, well, I need to give ABC company a price that I am willing to buy. Magkano ko bibilhin yung steel, wood, and labor ng ABC company? And that is my Y1, Y2, and Y3. Okay? And because I know that ABC company has 1,000 units of steel, 1,200 units of wood, and 1,800 units of labor, then if I get the sum product, this equation, this function is my total cost of purchasing the input materials of ABC company. And that is why I would like to minimize. Diba? So, if I am a company that would like to purchase these input materials from ABC company, of course, I'd like to minimize the cost of getting these. No? And of course, if you want to minimize the total cost, the tendency is for me to give a very very low price for the steel, wood, and labor. However, I cannot set the prices of these input materials to be very very low because of two particular constraints. Now, remember that every dual constraint pertains to a primal variable. And the first dual constraint pertains to x1, the first primal variable x1, and x1 is the production of red. And if you remember the problem, what are the coefficients 2, 0, and 3, and 500 relative to x1? If you look at the primal problem, 2, 0, 3 are in the first column, no? 2 is the amount of steel, 0 is the amount of wood, and 3 is the amount of labor for every unit of red gadget that ABC company wants to produce. And again, if you get the sum product of 203 and Y1, Y2, Y3, this left-hand side pertains to the value that ABC company will be getting if I offer each unit of steel, wood, and labor a price of Y1, Y2, Y3. Ito yung makukuha ng ABC company from me. Or it's the value that ABC company will get by selling their steel, wood, and labor from me. To me, no? And why is this left-hand side have to be greater than or equal to 500? In my point of view, I am the one buying the supply materials, no, from ABC company. In my point of view, I cannot set Y1, Y2, Y3 to be very very low. I need it to be set at a certain value so that this left-hand side is bigger than 500. Bakit? Why? Because if this left-hand side is less than 500, then in the point of view of ABC company, they will not sell me their steel, wood, and labor. Why? Because they will get uh, lower lower value or lower profit from selling the input materials to me. They would rather produce the red gadget and get a profit of 500. And at the same time, the sum product of 0, 2, and 2 multiplied with Y1, Y2, and Y3 is the value that ABC company will get for every blue gadget that they don't produce. And of course, as a constraint, the value that ABC company will get for every blue gadget they decide not to produce will have to be at least 300 so that ABC company will be persuaded to sell the materials to me instead of building or producing the blue gadget. And that is how we understand the dual problem of the red blue gadget problem. And I'm guessing for every primal and dual problem, this is how we frame the dual problems definition, or how we understand the dual problem.